So here let us find the centroid of the line. Okay, now consider a homogeneous wire. Now this is a homogeneous wire of uniform cross section A. The cross section of this wire, let it be A. The total length of this wire from point 1 to point 2, let's take it as L. Okay, and then the density, take it as rho here. So in this particular equation, to find out the centroid of the line, let us divide this particular wire into a small element. Then let us find out the weight of the element. So here imagine that we have divided this particular wire here, and the length, let it be dl, the small length. Okay, now weight of this particular small region will be equal to weight of the element is equal to, that is dw will be equal to rho into g into the volume is nothing but dl, the small length, into a, cross sectional area. So this is the weight of this particular small section here. Now the entire weight of the wire, by integrating this equation, let us take this equation as 1, integrating this equation, what we get here is W will be equal to rho A G into L. So this is the total weight of the wire. Now let us find the first moment of this weight. This wire, let us consider this to be as xn y here, and we'll take the center point, this distance to be y, this distance to be x. Now let us find out the moment at this particular point with respect to x-axis. So what we get here is nothing but the weight of the small element into the perpendicular distance from this axis. So that will be equal to the first moment what we get here is rho into A, that is cross section, G into dl into y. So perpendicular distance is y here. Now using the principle of moment, which states that moment of at a given point, at any given point, the resultant of the several forces that are there in this particular several concurrent forces will be equal to sum of individual forces. Like if I take over here individual forces, the weight of that into different y distance, y1, y2 or something, will be at the same point, will be equal at the same point. So we can write down this particular equation as, by using principle of moment, that is y dash into w, that is the whole weight of the wire, will be equal to integration of this particular weight of the first moment, that is integration of rho A G dl into y. So we know the value of w here, so substituting this equation in this, so what we get here is y dash into rho A gl is equal to integration of rho A G dl into y. To find out y dash, we can keep density as well as the cross section area will remain the same throughout this whole wire. Density and cross section area will remain same since it's a homogeneous wire too. So we can write this whole equation as y dash is equal to integration of y into dl by L. Okay. Similarly, from the x coordinate location, the center of gravity of the wire can be determined as x dash is equal to integration of x dl by L. So here we can conclude that basically the center of gravity does not depend upon the wire's cross section nor the density. Okay. So hence we can say that the center of gravity of a homogeneous wire of uniform cross sectional area is same as the centroid of its central line. Okay. Basically we can treat this wire into a line to find the location of its centroid.